Alright, let's look at factoring. This is the first video, and the first thing we want to look at is the factoring strategy. The first thing you do when you're factoring is you want to see if you can factor out a greatest common factor. Then we want to look and see how many terms we have. If we have two terms, we want to see, is it the difference of two squares, the sum of two cubes, or the difference of two cubes. Then if we have three terms, we want to see if it's a perfect square trinomial, and then we want to try to use the AC method, or we can use trial and error. And then if we have four terms, we can try factor by grouping. And we're going to look at every case. And of course we won't be able to fit them all into one video, so there will be several videos on factoring. So let's start out with working some problems factoring out the greatest common factor. But before we do that, let's see what is the greatest common factor. Well, the greatest common factor, that's the largest number that will divide into two numbers or three numbers, however many terms you have. So for example, if we have the number 16 and the number 24, we want to find the largest factor that will divide into 16 and 24. Well, 2 is a number that will divide into 16, and 2 will divide into 24 evenly. They're both factors of 16 and 24. But it's not the largest number. The greatest common factor of 16 and 24 would be 8, because 8 goes into 16 twice. It divides into there evenly, and 8 will divide into 24 evenly. It goes in there 3 times. Now 16 and 24, it's kind of easy to see what the greatest common factor is of 16 and 24. But let's suppose we have something that may not be so obvious. Let's take the numbers 36 and 48. Some of you may already know what the greatest common factor is, but let's say you don't. Well, the first thing we want to do is we want to take 36 and 48, and we want to write them as a product of prime numbers. So the way we can break that up is we know 36 is 2 times 18. 2 is a prime number. And if you need a review on prime numbers, you can get on the internet, you can Google it. Prime numbers are numbers where the only factors are 1 and the number itself. See, the only way we can get 2 is 1 times 2. So some prime numbers are 2, 3, 5, 7, 11, 13, and so on. Well, let's break 18 up. So 18 can be written as 2 times 9, and then 9 can be written as 3 times 3. So 36 written as a product of prime numbers would be 2 times 2 times 3 times 3. So we could write 36 as 2 times 2 times 2, times 3 times 3. Now let's look at the number 48. Well, 48 is 2 times 24. 24 can be written as 2 times 12. 12 can be written as 2 times 6, and 6 can be written as 2 times 3. So 48 written as a product of primes would be 2 times 2 times 2 times 2 times 3. So we can write 48 as 2 times 2 times 2 times 2 times 3. Now, to find the greatest common factor, let's see, I got some room up here. The greatest common factor, or the GCF, okay, we look at each different term, okay, each different prime factor. So let's look at the 2. So the 36, the 2 appears twice, and in 48 the 2 appears 4 times. So to find the greatest common factor, we take the 2 the least number of times it appears. So in 36 it appears twice, in 48 it appears 4 times. The least amount of times it appears is twice, so that's how many times we use it. Now let's look at the 3. Here the 3 appears twice, and in 48 the 3 appears once. So the least number of times it appears is once, so that's how many times we use it. So the greatest common factor would be 2 times 2 is 4 times 3 is 12. So there's our greatest common factor, 12. Let's take a look at another one. We want to find the greatest common factor of 12x squared y squared, 30x squared yz, and 42x cubed y. So once again we can find the greatest common factor of 12, 30, and 42. Okay, the greatest common factor of 12, 30, and 42 is 6. Now if you don't see how we get that, you can take the 12, 30, and 42, write it as a product of primes like we did here, and find the greatest common factor as we did in this problem. Okay. Now let's talk about the variables. Alright, we have x squared, and then we have this x squared, and then here we have x cubed. Okay, and if we write these out, x squared is x times x. The x squared is x times x, and x cubed is x times x times x. Now for the greatest common factor, we look at this, and the x here appears twice, here it appears twice, and here it appears 3 times. So the least number of times it's used in any of them is twice. So that's how many times we use it, twice. So we have x times x. Now let's look at the y. So here we have y squared, here we have y, and here we have y. So this is y times y. Y is just equal to y, it's just one time, and same thing here. So with y squared, the y appears twice, once, so we use it one time. So that's times y. Now let's look at the z. Notice z is just in this term here, 30x squared yz. So you notice the z appears once. In this one it appears 0 times, and in this one it appears 0 times. So the least amount of times it appears is 0, so we don't use the z any. So that gives us a greatest common factor of 6x squared y. And here's our greatest common factor. Now, to make it a little easier, whenever you're looking at variables with exponents, the one you use is the one with the smallest exponent. So another way we can look at it is we have x squared, x cubed. The smallest exponent is x squared. Okay, so that's what we would use, the x squared. And with the y's, we have a y squared, we have a y, and we have a y. The smallest exponent, now remember the exponent's understood to be a 1. So the smallest exponent is 1. So that's the one we use. Now for the z, we can see that here the exponent is 1. Now in this problem there's not a z, but remember that could also be written as z to the 0 power, because anything written to the 0 power is 1, and z to the 0 is 1, and 1 times x squared, y squared, x squared 12 would just give us the x squared 12x squared y squared. And same thing here, this is like z to the 0. I mean, we don't write it, but that's one way we can look at it. So we can see that we have an exponent of 0, 1, and 0. The smallest exponent is 0, so we don't use the z any. Okay, so I hope this video here helped you understand how to find the greatest common factor. We're going to have to use this in order to do this first step here, factor out the greatest common factor. And I hope you'll watch the next video. Thanks.